Good evening or good day. All right, so here we're going to go over some problems, two of the series, and they'll be kind of the last ones I'm going to post for next week or so. I'm going to do more, like I said in the announcement page, just more informational stuff. But I did say I was going to post this, so I want to make sure I get it done before we get really into the AP testing time. So just remember, please study for APs, stay awake. During the times you don't want to be up at 9 a.m. for the first time in weeks if you normally sleep till like 10 or 11, whatever. So just get used to getting up during that time so you're functional during that time. Anyway, so what I like to do in problems like this is to kind of label everything on the circuit itself. So here's kind of the table to kind of fill everything in, but here's the schematic. So here normally, remember, you have two big lines. So this is the positive and this is the negative. This will be your battery. And right here I said it's going to be 12 volts. That's the potential energy that the electrons have as it's traveling through the circuitry. Resistors, like I said, are just objects in the way, making electrons doing work. In this case, we have some properties of them. Here we have something that's 5 ohms. Here we have something that's 3 ohms. And here we have something that's 4 ohms. So it could be anything. This is usually related to something called power, which we'll eventually get into. So a lot of your devices are rated by wattage, like how much watts it takes. Light bulbs are now in the tens or fives. It used to be in the hundreds and 60s. Let's see what else. Your video games, your cell phones are usually about 5 watts or 10 watts charging. So that's kind of where we are now. And from that, you can figure out how much resistance they have. We want to be able to figure out how much voltage is going through each thing and how much current is going through each thing depending on what circuitry it is. So in this case, it's series. So we have the following properties. If you remember, voltage is the sum. So V total is equal to V1 plus V2 plus V3, etc. No matter how many you have here. Current is the same. So I total is equal to I1 plus I2, equal I2 equal I3. And then resistance is also the sum of R1 plus R2 plus R3, etc. So in this case, we're going to figure out what we could do here. Current's all the same, but we don't have any idea. Voltage is the sum of, but we don't have anything. But we do know resistance. So we can add these up. 5 plus 3 plus 4 will give us 12. I try to make the resistance easy to do. So we also have this equation V equals IR, and this is true for all things. So V times something equals, V equals something times 12. So that will give us 1. So 1 amp times 12 will give us 12 volts. Now remember here, all the currents are the same. So that means all these are going to be 1, and then you're pretty much done. Now it's just 1 times 5 is 5. 1 times 3 is 3. 1 times 4 is 4. And then you could check 5 plus 3 plus 4 gives us 12. So it's kind of like a Sudoku. Kind of, you have all these different patterns that you could do. I personally find these a lot of fun to do. They're kind of just nice puzzles that are entertaining. So I enjoy doing these. Our next one looks a little bit more complicated, but it's actually fairly simple. Same rules. So let me put it back into our pen. Let me rewrite it again. So undo. Change it. I don't know why it got so big. So V total is the sum. Current is the same. And then resistance is the sum. So now we have 1, 2, 3, 4, 5. You can label it if you like. But we could do it this way as well. Since we know that current is the same, if I give you 1, all these are 1. Then you know that this has to equal 12. I made the math easy. So now you know this is 1, this is 3, this one is 4, this one is 2. Now you could do a couple ways. You could add these and look for the missing here or here. Either way will work. 1 plus 3 is 4 plus 4. Did I mess up? Oh, shoot. 4. No, I didn't. Haha. 4 plus 4 plus 2 gives us 10. So that means this one has to be 2. So 1 times 2 is 2. So that's kind of how you solve these. They're very simple in this case. Then we're going to do parallel. I'm not sure when. I'm going to try to figure it out. And then we'll see you guys after. We'll see. I'm still debating how to do the next 3 weeks, but we'll see. But it'll be light. Just check in. Most likely it'll just be cool stuff about electricity. Maybe I'll even do cool stuff about astronomy. So we'll see where we go from here. All right, take care, guys.